Hi everyone, myself Konda Krishnudu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. Today I am going to talk about optical fibers. So particularly coming to overview of my presentation, today I am going to discuss about introduction to optical fibers, principle of optical fiber, advantages and disadvantages of optical fibers, and finally applications of optical fibers. So coming to introduction, so what is an optical fiber? What is an optical fiber? So optical fibers are very thin flexible dielectric waveguides. Optical fibers are very thin flexible dielectric waveguides. Why they are called dielectrics? Because optical fibers are made of either plastic or glass. Optical fibers are made of either plastic or glass. Both are insulators. So that is why optical fibers are also called as dielectrics, and why they are called as waveguides. So generally optical fibers carries information in the form of light from one place to another place. That light is nothing but electromagnetic wave. That is why optical fibers are called waveguides. So optical fibers are very thin, flexible, dielectric waveguides. Optical fibers uses light. They uses light pulse to transfer information from one end to the other end, or from one place to another place. So what happens when information is carried through light waves? So coming to this slide, we are going to observe the frequencies of radio waves, microwaves and light waves. So when compared with radio waves and microwaves, frequency of light waves is very high. It is about 10 power 15 hertz. This frequency is called optical frequency. Optical frequency. Whereas the frequency of radio waves is around 10 power 6 hertz. And the frequency of microwaves is around 10 power 10 hertz. So generally, information carrying capacity of any wave depends on its frequency. Information carrying capacity of any wave is always directly proportional to frequency. More is the frequency of wave, more it will carry the information. So from these figures, we can say that compared with radio waves and microwaves, light waves carries more information. Okay, so we came to know that light beam can transfer information from one place to another place. So what happens when light beams moves in the environment? What it happens when it moves in atmosphere? When it moves in atmosphere, it will be affected by atmospheric conditions like rain, fog and some others. Because of that, the efficient communication will be disturbed. Efficiency of information transfer will be disturbed. So to overcome that, definitely there is a guiding medium. There is a guiding medium. That guiding medium is nothing but optical fiber. That guiding medium is nothing but optical fiber. So optical fibers are very thin flexible dielectric waveguides which are used to transfer information from one place to another place without much loss in energy. Now, what is fiber optics? Fiber optics is nothing but the branch of physics which deals with the production and reception of light waves using optical fibers. The branch of physics which deals with the production and transmission of light waves using optical fiber is called fiber optics. Now, coming to the simple structure of optical fiber. Simple structure of optical fiber consists of three layers. What are those three layers? The middle layer of the optical fiber is core medium. It is in the form of a cylinder. This cylindrical core is surrounded by the second layer, what is called cladding, and this core cladding arrangement is covered with a protecting layer that is called jacket protection. So this is simple structure where we are observing three layers, out of which the middle layer of the optical fiber is core. So far we came to know that optical fibers transfers information from one place to another place. In which layer that light will be moved. So that light will move in this middle layer, what is called core medium. It will move through the middle layer called core medium, and you can observe in this diagram, middle layer of the optical fiber is core. In this core medium, light is moving. Okay, na? So never it enters into cladding. The reason that we are going to discuss in the next topic. Right? Now, coming to the principle of an optical fiber. So what is the principle of optical fiber? Principle of optical fiber is total internal reflection. Total internal reflection. So what is total internal reflection? That we are going to discuss in this particular topic. To discuss about that, we need to consider the cross-sectional view of the optical fiber. So this is the cross-sectional view where we are observing the middle layer, what is called core medium, whose refractive index is N1. This core medium is surrounded by the cladding medium, whose refractive index is N2. The basic condition that is required for the process of total internal reflection is N1 should be greater than N2. N1 should be greater than N2. Refractive index of the core should be always slightly greater than refractive index of cladding. Means here core medium is considered as denser medium. Core medium is considered as denser medium. Now, a ray of light is moving from core medium towards cladding. This is normal drawn to the boundary. This is the point where the light beam is moving from core medium to cladding medium. So generally, the property of light is that it always travels in straight lines. It has rectilinear propagation. What happens when light moves from one medium to another medium of different refractive index? In that case, what happens is, it slightly deviates from its straight line path. In the absence of the second medium, generally it should have to travel like this. It should have to travel like this. But due to the presence of another medium, it slightly deviates from its straight line path. This deviation is called refraction, and this ray is called refracted ray. This is angle of refraction. Here theta is taken as angle of refraction, which is nothing but the angle between the normal drawn to the boundary and the refracted ray. Now, this is the diagram where the condition is considered as phi is less than phi c. Means angle of incidence is less than critical angle. In that case, what is happening? Light beam is simply refracting into the second medium. Now, this is the condition where the angle of incidence is equal to critical angle. Here theta c is nothing but critical angle. So what happens when the angle of incidence is equal to critical angle? So generally when we increase the angle of incidence, angle of refraction also increases. At a particular angle of incidence, what happens is angle of refraction becomes 90 degrees. The angle of incidence at which it happens is called critical angle. So the angle of incidence for which angle of refraction is 90 degrees is called critical angle. Now, what happens when we further increase the angle of incidence at core cladding boundary? When the angle of incidence is greater than critical angle, in that case, instead of refraction into the second medium, the light ray simply reflects into the same medium. The light ray simply reflects into the same core medium. This is what is called reflection, or particularly we can say it as total internal reflection. So how to understood this word total internal reflection? The total light which is falling on core cladding boundary coming back into the same medium when the angle of incidence is greater than critical angle. In that case, the process is called total internal reflection. So this is the process by which the light beam moves from one end to the other end of the optical fiber. This is the process what is called total internal reflection. So finally, we can understood that there are two basic conditions which are required for total internal reflection to take place. One is angle of N1 should be greater than N2. Refractive index of the core should be greater than refractive index of cladding, and angle of incidence should be greater than critical angle. So if these two conditions are satisfied, in that case light beam moves from one end to the other end of the optical fiber by the process called total internal reflection. Because of this process only, optical fiber efficiently transfers information from one end to the other end without much loss in energy. Losses will be there, but those losses are minimized to a great extent because of this principle, what is called total internal reflection. Now, coming to the advantages and disadvantages of the optical fiber. So, optical fiber has so many advantages. It has less attenuation. Just now I told that without much loss in energy, it can transfer information. Yes, the losses are minimized. Attenuation means here it is nothing but the loss that is taking place while the light beam is moving from one end to the other end of the optical fiber. Second one is optical fiber transfers information at a faster rate when compared with the conventional cables. Next, less impervious to the electromagnetic interference. In the beginning, we came to know that optical fibers are made of either plastic or glass. They are called insulators, or we can say non-conductors. Because optical fibers are made of non-conductors, there is no question of electromagnetic interference when the information is carried through them. That is what is called less impervious to electromagnetic interference. Next, smaller size. Optical fibers are smaller in size and the information carrying capacity is more. They have more information carrying capacity because they will carry information around 10 power 14 to 10 power 15 hertz. These are the advantages of the optical fibers. Now, coming to the disadvantages. So, generally optical fibers are cost, and then they are delicate, and much experience is required while handling these optical fibers. These are the disadvantages. And finally, I am going to conclude this session with the applications of optical fibers. Optical fibers have so many applications in various fields of science and technology, particularly in medical field. They are used in endoscopes. Optical fiber endoscopes, they are used to see the internal organs of the human body while treating for so many diseases. And secondly, information while passing through the optical fibers, it is very highly secured. Because of that high security, these optical fibers are used in the instruments. Okay, now particularly they are used in defense. Next, broadcasting. The main applications of optical fiber lies in the field of communication, because they will transfer information at a higher bandwidth and they will carry more information when compared with the conventional copper cables. And finally, not only in the technical field, optical fibers are also used in general household decorating items and some other purposes in our daily life. So, like this, optical fibers have so many applications. And coming to the summary. So, today just we discussed about the introduction, the principle of an optical fiber, as well as the advantages and disadvantages. So, in the next class, we are going to discuss about types of optical fibers. So, thank you.